Okay, in this section, we are going to look at defining 6 trigonometric functions. And these functions are based on a right triangle. So we're going to start with that. Um, what I want us to do is to try to remember before we get started what we already know about a right triangle. All right, so I know that a right triangle has a 90-degree angle inside the triangle. That's what makes it a right triangle, having a 90-degree angle. Okay, so what else do I know? For right triangles, I know that um, the Pythagorean theorem works. Okay, now a right triangle is the only kind of triangle that Pythagorean theorem works for, but it does hold. And this deals with the sides of the triangle. So remember that this basically says that a squared plus b squared equals c squared. All right, so when we're talking about using that Pythagorean theorem, normally our hypotenuse of our triangle, the slanted side that is across from the right angle, this is always the C. Okay, so the side opposite the right angle is typically the side that we label C. And then the A and the B are the other two sides, and it doesn't really matter which one is which. So you could put A here, you could put B here, it doesn't matter. You could put B down here or A down there, either way. Okay, A and B refer to the legs of the triangle. C refers to the side that's opposite the right angle. So that holds for the sides. And you probably remember that from an algebra class, maybe in high school. All right, so the second thing that we want to remember deals with the angles. So when we have any triangle, right triangle included, if you take all 3 of your angles, all right, so you've got an angle here, we've got an angle down here that we've already noted, and we've got an angle right here. So if I take all 3 of those angles and I add them up, that should equal 180 degrees. Okay, so those are the 2 things that you want to keep in mind as we move forward in this section. These are things that you really should know. We're just kind of reviewing those 2 ideas. All right, so now we're going to bring in those trigonometric functions, and there are 6 of them. Okay, so if you've had any trig before, hopefully you're going to recognize the name of these functions. I just have 3 of them up here right now. There are 6, so we're going to add the other 3 in just a minute. All right, so we have a sine function, we have a cosine function, and we have a tangent function. And so these are our main 3 trigonometric functions. You can see that we have some abbreviations that are in this column. All right, so that every time we're talking about sine, we don't put the E, which obviously is no big deal, but for cosine, we abbreviate it COS. For tangent, we abbreviate it TAN. And when you're talking about these functions, you're always going to have an angle, okay? These functions are defined in relation to an angle. So you will always see sine, that's the function name, and then the theta, which refers to an angle, or, depending on the problem, it might have a specific angle in there, like sine of 90 degrees. Okay, so I'm going to go back to my right triangle. I'm going to go ahead and mark my right angle at the bottom here. All right, and I'm going to put another angle in the triangle. I want to mark some angle theta. Now, right now we're keeping this really general, so I can either put theta up at the top or I can put theta at the bottom. It does not matter. I'm going to stick it down here at the bottom. But all this refers to is that there is some angle down at the bottom of the triangle. Okay, so we know the hypotenuse of the triangle, the C side, is across from the right angle. So I'm just going to put an H. H is going to stand for hypotenuse of the triangle. Okay, I'm just going to kind of write this up here so we don't forget. All right, all right. Now, when I look at my angle theta, I'm going to trace across my triangle to the side opposite that. This is going to be my opposite side, and I'm just going to use O for opposite. Okay, so we'll place our angle theta, and then the side across from it, that is going to be the O. And then the other side, which is technically the side next to the angle that we're looking at, that's going to be A, and A is going to stand for adjacent. Adjacent just means next to. Okay, so now I'm going to go back to my functions, and I am going to define these functions based on these three sides. All right, so for the sine function, we are going to use a fraction for the definition that's going to be the opposite side divided by the hypotenuse. Okay, so that's the definition of the sine function. You're going to take your triangle and you're going to use your opposite side divided by your hypotenuse, and that's going to give you your sine function. For your cosine, you're going to use adjacent over hypotenuse. And for tangent, you're going to use opposite over adjacent. Okay, now if you have done some trig before, you know that there is a device that we use to help us remember this called SOHCAHTOA. All right, so it sounds kind of funny. We'll say it a few times and hopefully it'll stick. SOHCAHTOA will help you remember the order that you need to do things in. So what it basically says is that you're going to take the S for sine and the O and the H, and now you have this SOH. Right, and then you're going to take the C for cosine and the A and the H, that spells the ka part. And then for the last one, you've got the T in tangent and the O and the A, and that's the TOA part. So if you can remember SOHCAHTOA, then you can remember the definitions for these first three trig functions. Okay, now the other three trig functions, remember there's 6 and we've only done 4. The other 3 are based off of reciprocals of the first 3. So the fourth one we're going to use what's called a cosecant function. And this one is going to be abbreviated CSC. And it is going to be the reciprocal of the sine. So if the sine is O over H, the cosecant is going to be H over O. All right, and then the fifth one is going to be the secant function. We're going to abbreviate this SEC. And again, it's going to be the reciprocal of the cosine. So if cosine is A over H, this one is going to be H over A. All right, and then the last one is the cotangent function. We're going to abbreviate this one COT, and it is going to be the reciprocal of the tangent. So if the tangent is O over A, This one is going to be A over O. All right, so now we have definitions for all 6 of the trig functions. Okay, I'm going to stop right there for a minute, and I'm going to do another presentation where I show you a couple of examples.